Am I audible? Please, someone raise your hand. Okay, I got it. Thank you. Thank you, Swayam. I will start class within 2 minutes. I'm waiting for the students to join in. Right now, only there are 13 members present in the meeting. Only 13 participants. 14, 15, now it is rising. Okay, Tanush, important questions beku. Okay, important questions. Node, first to state uncertainty principle and show that electrons are not present inside the nucleus. Okay, ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಇದು. ಇದರಲ್ಲಿ ನೀವು ಕಲ್ತಿದ್ರೆ ಗೊತ್ತಿರುತ್ತೆ, electrons are not present inside the nucleus ಗೆ ಒಂದು relativistic method ಇದೆ. If electrons are inside the nucleus, the energy should be 20 MeV ಅಂತ ಬರಬೇಕು. ಆಯ್ತಾ, ನಾನು ಕೆಲವರಿಗೆ ನೋಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ ಹಳೇದದು, ಅದು ನಾನ್ ರಿಲೇಟಿವಿಸ್ಟಿಕ್ ಕೇಸ್ ಅಂತ, ಅದರಲ್ಲಿ 80 MeV ಅಂತ ಬರ್ತಿತ್ತು. ಆಯ್ತಾ, ಅದನ್ನ ರೆಫರ್ ಮಾಡಬೇಡಿ, ನಿಮಗೆ HOD ಸರ್ ಏನ್ ಕಳ್ಸಿದಾರೋ ಆ ನೋಟ್ಸ್ ರೆಫರ್ ಮಾಡಿ. ಈ ಸಲ ಹೊಸ ಇನ್ಕ್ಲೂಷನ್ ಅದು 20 MeV ಬರೋ ಕಡೆಗೆ ನಮಗೆ ಬೀಟಾ ಡಿ ಕೆ ಅಲ್ಲಿ 4 MeV ಬರ್ತಾ ಇರುತ್ತೆ ಅಂತ. ಆಯ್ತಾ, ಅದು ತರ ಬರಿಬೇಕು. ಅಲ್ಲಿಗೆ ಫಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್, ಸ್ಟೇಟ್ ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಅಂಡ್ ಯೂಸಿಂಗ್ ದಟ್ ಶೋ ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ನಾಟ್ ಇನ್ಸೈಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ ಕ್ವಶನ್. ಸೆಕೆಂಡ್ ಕ್ವಶನ್ ಏನು ಅಂದ್ರೆ, ಸೆಟಪ್ ಸ್ಕ್ರಾಡಿಂಜರ್ಸ್ ಟೈಮ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಇಕ್ವೇಶನ್. ಆಯ್ತಾ, ಥರ್ಡ್ ಕ್ವಶನ್ ಈಸ್ obtain eigen values and eigen functions of a particle trapped in one dimensional box. This is third question. Okay. Okay. ಆಮೇಲೆ ಕೆಲವು ಡೆಫಿನೇಷನ್ಸ್ ಆನ್ ಬ್ಲಾಕ್ ಬಾಡಿ ರೇಡಿಯೇಷನ್ಸ್ ನೆನಪಿರ್ಬೇಕು. ಪ್ಲಾಂಕ್ಸ್ ಲಾ, ಪ್ಲಾಂಕ್ಸ್ ಇದು ಏನು ಅಸಂಪ್ಷನ್ಸ್, ಸ್ಟೀಫನ್ ಬೋಲ್ಟ್ಸ್ಮನ್ ಲಾ, ಜೇಮ್ಸ್ ಲಾ, ಈ ತರ ಎಲ್ಲ ಇರುತ್ತೆ. ಮೇನ್ 3 ಕ್ವಶನ್ಸ್ ಅನ್ನ ಹೇಳಿದ್ವಿ. ಪ್ರತಿ ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ 4 ಮೇನ್ ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ. ನೀವು ಐದರ್ 1 or 2 ಅಂಡ್ 2 or 3 or 4 ಇಂಟರ್ನಲ್ ಚಾಯ್ಸ್ ಅಂತ ಕರೀತಾರೆ, ಆ ತರ ಆನ್ಸರ್ ಮಾಡ್ಬೇಕು. ಆಯ್ತಾ, ಇನ್ನೇನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ ಯಾರಿಗಾದ್ರು? 7 ಮಾರ್ಕ್ಸ್ ಇಂದು ಮೇನ್ ಕ್ವಶನ್, 3 ಮಾರ್ಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ ಪ್ರತಿ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ. ಆಯ್ತಾ, ಇನ್ನೇನೇ ಕ್ವಶನ್ ಡೌಟ್ಸ್ ಇದ್ರು ನನಗೆ ಮೆಸೇಜ್ ಮಾಡಿ, ನಾನು ನೋಡಿದ್ಮೇಲೆ ಅದನ್ನ ರಿಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಆಯ್ತಾ, ಲೇಟ್ ಆಗ್ಬೋದು, ಅದು ರಿಪ್ಲೈ ಮಾಡ್ತೀನಿ. ಮೂರು ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಗೊತ್ತಾಯ್ತಾ ಎಲ್ರಿಗೂ? ಗೊತ್ತಾದ್ರೆ ಯಾರು ರೈಸ್ ಹ್ಯಾಂಡ್ ಮಾಡಿ, ಹ್ಯಾಂಡ್ ರೈಸ್ ಮಾಡಿ ಸರ್. Okay, 3 participants raise their hand. Sir, can you explain once again important questions? Important questions explain ಮಾಡೋದಂದ್ರೆ ಫಸ್ಟ್ ಸ್ಟೇಟ್ ಮಾಡ್ತೀನಿ. ಸ್ಟೇಟ್ ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ and show that electrons are not present inside the nucleus using relativistic correction method. Relativistic method, ಆಯ್ತಾ? Relativistic method ನಿಮಗೆ ನೋಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಸರ್, ಅದರಲ್ಲಿ ಇದೆ ನೋಡಿ. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್, ಸೆಟಪ್ ಸ್ಕ್ರಾಡಿಂಜರ್ಸ್ ಇಕ್ವೇಶನ್. ನಾನು ಕೊಟ್ಟಿರೋ ನೋಟ್ಸ್ ಅಲ್ಲೂ ಇದೆ, ಅಂದ್ರೆ ನಾನು ಕೆಲವರಿಗೆ ಕೊಟ್ಟಿದ್ದೆ, ಬೇಕು ಅಂದವರಿಗೆ ಸರ್ ನೋಟ್ಸ್ ಅಲ್ಲೂ ಇದೆ. ಆಮೇಲೆ ಥರ್ಡ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್, obtain eigen value and eigen functions of particle trapped in one dimensional box. ಲಾಸ್ಟ್ ಡಿರೈವೇಶನ್ ಇಲ್ಲ ಅದು. ಇದು 3 ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್. ಅದಾದ್ಮೇಲೆ ಯು ಹ್ಯಾವ್ ಟು ಲರ್ನ್ ಅಬೌಟ್ ಪ್ಲಾಂಕ್ಸ್ ರೇಡಿಯೇಷನ್. ಆಯ್ತಾ, ದಟ್ಸ್ ಇಟ್. ಇನ್ನೇನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಆಮೇಲೆ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಅಷ್ಟು ಮಾತ್ರ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ. ವರುಣ್ ಥ್ಯಾಂಕ್ ಯು ಅಂತ. ಥ್ಯಾಂಕ್ಸ್ ವರುಣ್. ನನ್ನ ಕಡೆಯಿಂದ ಕ್ವಶನ್ ಕೇಳಿದಕ್ಕೆ. ಓಕೆ, only there are 35 participants. I think all other students are busy in preparing for the internals, and don't panic. Learn, I mean, as much as you can. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಪುಷ್ ಮಾಡಕ್ ಹೋಗಬೇಡಿ. ಸ್ಕೋರ್ ಗುಡ್ ಇನ್ ದ ಎಕ್ಸಾಮಿನೇಷನ್. ಎಷ್ಟು ಓದಿರ್ತೀರೋ ಅಷ್ಟು ಸ್ಕೋರ್ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಇಂದ ಮತ್ತೆ ಪ್ರಿಪೇರ್ ಆಗಿ ಈಗಿಂದಾನೆ. ಮಾಡ್ಯೂಲ್ ಯಾವ್ದು ಇರುತ್ತೆ ಅಂದ್ರೆ ಮಾಡ್ಯೂಲ್ 3 ಇರುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಇಂಟರ್ನಲ್ಸ್ಗೆ. ಆಯ್ತಾ? ಡೈಲಿ ಒಂದೊಂದು ಡಿರವೇಶನ್ ಕಲ್ತ್ರೆ ಬರೀ 4 ದಿನದ ಕೆಲಸ ಇವೆಲ್ಲ. ಆಯ್ತಾ? ನೀವು ತಿಂಗಳು ಪೂರ್ತಿ ಆಟ ಆಡ್ಬಿಟ್ಟು ಹಿಂದಿನ ದಿನ ಓದಕ್ ಹೋದ್ರೆ ಟೆನ್ಷನ್ ಆಗಕ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಆದ್ರೂ ಈಗಲೂ ಏನ್ ಟೆನ್ಷನ್ ಆಗ್ಬೇಕಾಗಿಲ್ಲ, ಕರೆಕ್ಟ್ ಆಗಿ ಓದಿದ್ರೆ ಮುಗಿಯುತ್ತೆ. ಸರಿ, ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. We were actually discussing about conductors, right? In the previous class, we have discussed about classical free electron theory. I mean, I hope you all remember that. It is very long back, okay? And I have actually stated the assumptions of quantum free electron theory, okay? And I have said to reduce the number of, actually, what is the main drawback of classical free electron theory? In the classical free electron theory, the conductivity expression contains all the constants except the number of free electrons, n. If number of free electrons is more, the conductivity will be high. According to that, aluminum must be good conducting than copper, which is a experimentally wrong observation. Okay, therefore we required, okay, I mean, we require a new theory that is nothing but a modified theory used by Sommerfeld. Okay, Sommerfeld is the scientist who actually developed this quantum free electron theory. These are the glimpses what I am giving now. These are already said and done. To reduce that number of free electrons, we introduce the concept of density of states. Okay, this is like counting the benches before counting the number of students, counting the benches, how many states are there, and then calculating how many states are occupied. And to understand the occupation probability, we have discussed a factor known as Fermi factor. Okay, Fermi factor can take values between 0 and 1. If the particle is definitely present, then you will get 1 as Fermi factor. Okay, if you don't have electron in the state, you will get Fermi factor equal to 0. Okay, all these things are already discussed. And in the previous class, I think I have discussed the temperature dependence of Fermi factor. Okay, temperature dependence means, I mean, at absolute zero, you will get this Fermi factor equal to 1 for all the energy levels below Fermi level. Okay, all the energy levels below Fermi level are completely filled at 0 Kelvin. Therefore, f of E must be equal to 1. And all the energy levels above Fermi level should have f of E or Fermi factor equal to 0. Okay, and then two participants raised their hand. What is the reason? Have you raised the hand because somebody else has also raised? I have not asked anything. Please down your hands. No need. Okay, and these are all things which are actually explained. Now today I will actually derive a important concept from the point of view of examination. Okay, I'm going to derive the expression for electrical conductivity of conductors. This was not there in the previous academic semester. This was new inclusion. This is a new inclusion, and it will be for 6 to 8 marks. Okay, in the examination, direct question will be given: obtain electrical conductivity of conductors. I hope you can recall, we have actually calculated electrical conductivity of semiconductors also. Okay, and I have actually written semiconductors under double inverted comma and said always make sure you are reading that last word. Okay, because in the examination they may ask you to obtain electrical conductivity for semiconductors, or they may also ask you to obtain electrical conductivity for conductors. You cannot interchange them. First, if they have asked for semiconductors, you have to do that derivation. If they have asked for conductors, you have to do the derivation, which I am going to explain right now. Okay, I mean, somebody has said that Subhadra ma'am has also started the class now. Why she started class? Somebody tell her. It's my class, right? 11:40 is my schedule. Which subject she teaches? Is there someone? I mean, somebody is messaged as Subhadra ma'am also started the class now. Why she has started class? Message her that this is my class. Okay, forget about her class. Okay. Now, in this class, I will derive electrical conductivity for conductors, and it is pretty similar to the derivation that I have done for semiconductors. I actually know that you have forgotten that derivation, okay? But once you start to read, you will find the similarities between the conductivity derivation for semiconductors and conductors, and that will actually help you to gain marks. Okay. Now, in conductors, I will start. I mean, I will give the notes later. I have not shared the notes for this derivation. Okay, the derivation starts with the statement that I have considered a cylindrical material of conductor of length L, okay, and area of cross section A, to which I have connected a battery, and because of this, there is an electric field in this direction. Okay, this is the basic assumption. Electron will move from negative terminal to positive terminal, right? And electric field is from positive to negative terminal. This is the direction of electric field, and this is the direction of electron motion. Okay, these are the preliminary ideas I will write in the notes. Okay, I have considered a cylindrical material of conductor of length L, area of cross section A, and to which I have connected a battery. Don't write anything on the screen. Okay, I have not I mean disabled notation. Okay, forget about it. Somebody has written, please erase it. I can't erase it. Okay, leave it. Now, with this assumption, let me show some animations which will help you to understand uh, the method of, or the way of electron conductivity. Look at here. Okay, sorry. Okay. Uh, if you are able to see this GIF, please raise your hand. Okay, Imani has raised. Okay, I got it. You can see here electric field is in this direction. That is, positive of the battery is here and negative of the battery is here. Therefore, electrons will move like this. This is a clear picture. Okay, these electrons are free electrons which are not connected to any of the atom. They are free to move throughout the crystal. You can see this motion is known as drift velocity, drifting motion. This electron is not moving in the straight line path. It is actually drifting around the positive lattice. What are these positive signs present here? These are the atoms which has lost one electron. Okay, if the electric field is in this direction, means electrons will move towards the left. Okay, and let me show much more clear picture where you will also see the lattice vibration. These positive ions, as temperature increases, starts to vibrate, and they are actually responsible for the resistance that can be shown in the next diagram. If you have a conducting material of this type, a conducting wire will contain all these things inside it. Here, these pink materials are the free electrons. Okay, they are actually moving randomly right now because I have not shown any battery over here. And here, these green positive uh, dots are nothing but the holes. These positive things are the, sorry, not holes, sorry, these are the ions. Okay, lattice ions. And you can see there is a shaded crystal structure also given. It is a cubic crystal. These ions will occupy the lattice points, right? Therefore they are known as lattice atoms or lattice ions. Okay, these free electrons now move, and you can see also the lattice vibrations. If temperature rises, the amplitude of this vibration also increases, and collision between the free electrons and this lattice will also increase, and resistance increases. Okay, this gives the overall picture of conduction inside a semiconducting material, I mean inside a wire of conducting material wire. Okay, let me go to the derivation. Okay, now what is my aim? My aim is to obtain expression for conductivity. Okay, let me try that thing. This is, I will start with calculating the force acting on the electron. I hope you remember, if you multiply charge of the electron with the field, you will get the force, right? Coulomb's law is nothing but Q1 Q2 by R square, right? Force is nothing but Q1 Q2 by R square. Field is nothing but Q divided by R square. If you multiply one charge to the field, you will get the force. Therefore, force acting on the each electron under which this electron is moving towards left is given by F is equal to E into E. Call it as equation 1. And according to Newton's law, you know that this force also should be equal to m into a, where m is the effective mass of the electron and a is the acceleration produced inside the electron. Electron is now actually accelerating towards the left, towards the positive terminal. Okay, and you know that these two are equal. Ma is equal to ee. Therefore, acceleration should be equal to ee divided by m. I can write acceleration as velocity by time, right? I have replaced acceleration with drift velocity divided by something called as relaxation time tau. Do you remember what is the meaning of relaxation time? It is the time between two successive collision. What are the things which are colliding? The free electron is colliding with the positive atom, right? Positive atom and or positive ion and electron will coincide, collide, and hence electron will be scattered. That is known as resistance, right? Scattering of electron actually is known as resistance. And the time interval between two successive collisions is known as relaxation time. If the time interval is more, the electron will freely move towards the positive terminal and resistance will be lower. If the relaxation time is lower, if the relaxation time is small, that means the electron is frequently colliding with the lattice ion, and therefore it is not able for the electron to reach the positive terminal, and this electron will be scattered and resistance will be higher. Okay, that is the entire concept, right? Therefore, acceleration of electron inside the wire can be written as drift velocity divided by relaxation time, and that is nothing but E divided by m. Okay, I will call it as equation 4. I have obtained expression for drift velocity in terms of relaxation time. Okay, it is very simple. Let me explain once again. As soon as I apply a battery across a conducting wire, the electron will start to move towards the positive terminal of the battery. Okay, the velocity of the electron is given by V, and force acting on this electron is E into E. And according to Newton's law, ma should be equal to E into E. And acceleration A should be written as drift velocity divided by relaxation time. In terms of relaxation time, V can be written as E by m into tau, where tau is the time between two successive collisions. Okay, collision between free electron and the positive lattice ion. This is a abrupt thing which I have included, and I will call it as equation 4. And you will, further, you will come to understand why I have defined this velocity in terms of relaxation time later. Okay. Now let me ask you the question: what is the meaning of current? What is the basic meaning of current? It is nothing but total charges, rate of change of charges, right? Or motion of charges. That also can be written as total charges divided by time. Okay. How many charges are there? If there are, if n is the concentration of electron or n is the density of electrons, then how many electrons are there? N into Al. Okay. Concentration or density is nothing but number of electrons per unit volume, right? If I multiply this concentration with volume, volume is given by area into length. Area into length will give us the volume. Volume into concentration will give the number of electrons. Now, if there are n into Al number of electrons, how many charges are there? Each electron will have a charge E. Therefore, this thing NaL into E will give the number of electrons. Okay, NaL into E gives the number of charges, not number of electrons. It will give the number of charges divided by time t. What is this time t? This is the time taken by this electron. This is the time taken by the electron to travel this distance L. Okay, the length of the wire is L, right? The time taken by the electron to travel this length L is known as time t, and that can be given by this equation. Time t is equal to L divided by drift velocity. Okay, length by v. I hope you know v is equal to length by time. Therefore, time is equal to L by v. Substitute this L, substitute this t value in the equation 5. Okay, look at here. In I have substituted the value of t. Okay, I can cancel the length and I will be left with NA into EV. This step is very identical to the step which we have used in derivation of conductivity in semiconductor. I will call this as equation 7. This will give us the current. Okay. Now, how can you get the current density? Current density is nothing but current divided by area. Okay. You can cancel this area in the current and you will get NEV as current density. I hope you remember this thing. NEV is the current density. It is same in the semiconducting part. Now, I have actually derived it on my own. I have not looked into any of the textbooks. Therefore, at this point, I got stuck. I don't know how to proceed further. Okay. Then I thought, what to do next? What is our aim? Our aim is to find out sigma, right? Our aim is to find out the conductivity expression. And I have stuck here. And I made a wrong calculation. I actually introduced mobility into the picture, which is not necessary. And I thought I have made a mistake and I strike it out. Now, can you guess what I am going to do next after NEV? What I am going to do next? You remember V, right? I have obtained the expression for drift velocity here. You can see V is equal to E by M into tau. Bring it over here. Replace this V with E by M into tau. I'm taking all the vectors. I'm taking this vector symbol out. I'm just considering the magnitude. You can see NEV now become like this. EM by tau is V now. Okay. E into E square, and you will get this kind of a formula. Very trivial formula, right? There is nothing much to observe here. I just multiplied this thing. Now call it as equation 9. Now what you are going to do? I think I have shown that Ohm's law V is equal to IR can also be written as J is equal to sigma E. Okay. If you don't remember, I will do once again in the offline class. Okay. J is equal to sigma E is the Ohm's law. It is as same as V is equal to IR. Okay. You have to compare this Ohm's law with this equation 9, which contains J and E. Okay. If you compare them, you can cancel J and E and you will be left with the expression for sigma conductivity. Okay. Conductivity sigma is now equal to NE square tau into tau divided by M. This is the same expression what we are going to obtain if we have adopted classical theory. Okay, classical theory or classical free electron theory also gives same expression for sigma. There is nothing special over here. Now from this equation, again you can see this sigma is directly proportional to n, right? E and M are constant and tau is also constant. The relaxation time is also constant for a given material. Therefore, again, the sigma depends only on n, and it will give us the wrong result. It will show that again aluminum is good conductor than copper. The problem is not solved, right? Now, to solve this problem, I now introduce the concept of free mean path or mean free path lambda f and Fermi velocity. I hope you remember Fermi energy, right? Fermi energy is nothing but highest occupied energy at absolute zero, and the velocity corresponding to that energy is known as Fermi velocity. If there is any electron present near the Fermi energy level, that electron will move with the velocity known as Fermi velocity. Okay, and in the last class, I think I have said only these electrons which are very near to the Fermi energy level will participate in conduction mechanism. Okay, therefore this Vf is very important. And one more thing, that is mean free path. Do you know what is the meaning of mean free path? I have already said electrons will collide with lattice ions, right? Okay. The distance traveled by the electron between two successive collisions is known as mean free path. It is the free path left for electron without any collisions. Okay. Or it is the distance traveled by the electron between two collisions. If this distance is bigger, conductivity will be good. If this distance is smaller, that means electron is frequently colliding with positive lattice ion and resistance is developing inside it. Okay. I hope you get this point. Lambda f is the path traveled by the electron between two collisions. This should be higher to get good conductivity. Okay. Now I will represent this tau in equation 11 with lambda f and vf. You can see this relaxation time tau is now equal to this mean free path divided by velocity. Again, it is same as v is equal to length by time. Similarly, here I have also written the thing. Vf is the Fermi velocity, which is equal to lambda f by relaxation time, or I can write relaxation time is equal to lambda f divided by Vf. Okay. Now substitute. This is according to quantum mechanics again. There is no concept of Fermi energy in the classical free electron theory. Okay. This entire Fermi velocity concept is from quantum free electron theory. This is the modification actually done by Sommerfeld. He actually mathematically calculated the mean free path and he also averaged out the Fermi velocity. Okay. And represented tau in the terms of lambda f and Pf. Now rewrite the equation for sigma or conductivity in terms of lambda f and Vf, and this will give you 8 marks. Okay, this is the final step. The conductivity according to quantum mechanics or quantum free electron theory is given by Ne squared divided by m into lambda f by Vf. This actually explains two drawbacks of classical theory. The first drawback of classical theory is conductivity is directly proportional to sigma, right? That is the first drawback. And the second drawback is uh, the conductivity is inversely proportional to, you can see here, according to experiments, this conductivity is inversely proportional to temperature. But according to classical theory, this conductivity is inversely proportional to square root of temperature. This is the wrong assumption made by the classical free electron theory. Okay, this is wrong thing. 1 over root of T is wrong. Okay, sigma actually depends on reciprocal of first power, that is T, not on root of T. Okay, these are the two things. One is wrong calculation of sigma and wrong dependence of sigma on T. These are the two drawbacks of classical free electron theory. Now I will explain and I will show that this new expression for sigma calculated according to Sommerfeld quantum free electron theory solves these two drawbacks. Okay, that also is a important question from the point of view of examination. They will ask you to write the success of quantum free electron theory for 4 marks. Okay, direct question will be asked. Write down the merits of quantum free electron theory or success of quantum free electron theory. Okay, I think you remember. Similarly, there is a question on classical free electron theory. You have to write the demerits of classical free electron theory for 4 marks. And in quantum free electron theory, you have to write the success of quantum free electron theory. Okay. Now, the first thing, let me explain. Here, I know the expression for sigma depends not only on n. This sigma now depends on this ratio lambda by Vf. Okay, mean free path divided by Fermi velocity. Also, the sigma inversely proportional to m star. Here, I have not considered mere m. M is the mass of the electron. Instead of mass of the electron, I have considered m star, which is the effective mass of the electron. Okay, in the Sommerfeld theory, we have used the term effective mass. Effective mass is the actual mass of the electron inside the applied electric field. Okay, I mean, if the electron is freely moving, it has mass m. If I have applied some electric field, we have to consider its effective mass, which is slightly higher or lower than the usual mass. Okay, very slightly. These are the two things in addition with n we have to take into consideration while calculating sigma. Okay, let me repeat once again. According to quantum free electron theory, sigma not only depends on n but also depends on lambda and Vf as well as on m star. Now, coming back to the question of aluminum and copper. Of course, aluminum contains 2.13 times greater n or number of electrons than copper. This aluminum is 3.73 times lesser in lambda by Vf than copper. Okay, let me tell once again. N of aluminum is 2 times greater than copper, but this ratio lambda by Vf for aluminum is 3 times shorter than copper. Therefore, clearly this copper sigma is greater than aluminum sigma. Okay, ಅಂದ್ರೆ ಏನು n ಅಲ್ಯೂಮಿನಿಯಂ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ, ಆದ್ರೆ ದಿಸ್ ರೇಷಿಯೋ ಇದೆ ಲ್ಯಾಂಬ್ಡಾ ಬೈ VF ಕಾಪರ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ. Therefore, sigma of copper is greater than aluminum, and also you can see there is a slight variation in m star. The effective mass of electrons in aluminum is 1.08 times greater than that of copper, and clearly this m star is in the denominator. If m star is greater for copper, sorry, m star is greater for aluminum, sigma is lesser for aluminum, right? Again, it also proves the same thing. Since m star for aluminum is greater than that of copper and m star is in the denominator in sigma expression, therefore sigma for copper is greater than aluminum. Okay, thus one of the problems was actually solved by quantum free electron theory. Now conductivity is experimentally, conductivity is, expression is matching with the experimental observation. Therefore you are actually using copper as electrical conductors in your domestic use, right? ನಿಮ್ಮ ಮನೆಯಲ್ಲೆಲ್ಲ ಕಾಪರ್ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತಿದ್ರು ಅಂದ್ರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು quantum free electron theory, copper is a good conductor than aluminum, and that experimental observation is actually solved. Okay, and let us come back to the next thing. Temperature dependence of sigma. According to experimental observation, sigma is inversely proportional to temperature. Andre temperature rise ಆದರೆ conductivity ಕಮ್ಮಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. The conductor becomes insulator as temperature increases. Okay, temperature ಕಮ್ಮಿ ಆದ್ರೆ conductor becomes superconductor. ಇದು ಗೊತ್ತಿದೆಯಲ್ವಾ? At low temperature we will have superconductivity. According to classical theory, sigma is inversely proportional to square root of t. ಅದನ್ನು ಓವರ್ಕಮ್ ಮಾಡಕ್ಕೆ we have a explanation with our hand. The origin of resistance is the vibration of positive ions. ಇಲ್ಲೊಂದು ಪಾಸಿಟಿವ್ ಅಯಾನ್ ಇದ್ರೆ ಅದು ವೈಬ್ರೇಟ್ ಆಗುತ್ತೆ ವಿತ್ ಟೆಂಪರೇಚರ್, ರೈಟ್? ಟೆಂಪರೇಚರ್ ಜೊತೆ ವೈಬ್ರೇಟ್ ಆದ್ರೆ it has the more probability of colliding with electron. I have given the example of football goalkeeper. If the goalkeeper is moving, then he has the higher probability of colliding with the football or stopping the football. Similarly, if this temperature rises, the lattice vibration or this lattice ion starts to vibrate with higher amplitude, and there is a higher probability of collision between conducting electrons and the lattice. Therefore, resistance increases, conductivity decreases, right? If I call this amplitude of vibration by the term R, if R is the amplitude of vibration of this lattice ion, okay, as temperature increases, this R also increases. Okay, let me tell you the theoretical concept. Energy of a vibrating body, that is this positive ion, is directly proportional to the amplitude. If the amplitude is higher, energy will be higher. Okay, and you also know that if the temperature is higher, energy also higher, right? Therefore, R square is directly proportional to T. Okay, this is obvious. And now think about lambda, that is mean free path. Mean free path is the distance, or it is the free path traveled by the electron between two successive collisions. Now you simply observe that if the amplitude of the lattice ion is higher, then collision probability is higher and mean free path will be lower. Therefore, this lambda mean free path is inversely proportional to the amplitude of vibration of lattice ions. Okay, therefore clearly lambda is inversely proportional to R square. and you have seen that r square is directly proportional to t. Therefore, lambda is directly proportional to 1 over t by these two arguments. You have seen vibrate, if the amplitude of the vibration is higher means energy of the oscillator is more. Okay, E is directly proportional to R square. Also, if the temperature is higher, energy of the particle is higher, right? Therefore, R square is directly proportional to T. And you know that if R square is higher, collision will be higher. If collision will be higher, mean free path will be lower. Therefore, lambda is inversely proportional to R square. Or you can say lambda is inversely proportional to T. Therefore, you can see here lambda is inversely proportional to t and it is directly proportional to sigma, and that implies sigma is inversely proportional to t, and this is in good agreement with the experimental observation. Okay, in this way I have solved the two. I am not the one who has solved it. Is a Sommerfeld using his quantum free electron theory solved the problem of temperature dependence of sigma. Okay, these two are the success of quantum free electron theory, and this from with this I have concluded the conductors part of the module 4, and I hope I have completed dielectrics and semiconductor for you guys. That means module 4 is over. In the next class I will solve few problems on conductors and then we will go to the module 3. And once again I will repeat, don't panic about the online classes. If you have not understood the concept during the online class, please ask me. Okay, I will repeat the classes in the offline mode, and I will make sure you understand the concept in a better manner. Okay, thank you very much for participating, and feel free to inquire about any difficulty that academic difficulty that you follow that you encounter. Okay, thank you very much. I'm going to stop the class right now.